Hello all. So today let's solve this lead code problem, which is add two numbers. So first let's read the problem description. So here they say you are given two non-empty linked lists representing two non-negative integers. So the digits are stored in reverse order and each of their nodes contain a single digit. All right. And the two numbers, add the two numbers and return the sum as a linked list. You may assume two numbers do not contain any leading zero except the number zero itself. Alright, so this is a fairly straightforward question. So let's try to understand a bit more using the diagram they have given here. So in this example one, we have two linked lists. So the first linked list contains 2, 4, 3, and the second linked list contains the numbers 5, 6, 7. So now what we have to do is we have to reverse these numbers first, right? So they have given that the digits are stored in reverse order, right? So what they do, so they take this first list 243, they reverse it, and they we get 342, and they get the and then they take the second linked list, which is 564, they reverse it, so we get 465. And now when you add 342 and 465, you get 807, and you have to construct this integer 807 as a linked list. So and be mindful that you should construct this in a reverse order. So you see the output as 807, but then your linked list or your output linked list will have 708, because we initially reverse it and did the addition. So after the output we have to reverse it again. So that's a fairly straightforward question. So what let's try to reiterate this one more. What we have to do, we have to take these two linked lists, we have to reverse them first, and after reversing we have to add those two numbers. After adding, we again have to reverse the number and construct a linked list like this. So that is all the question, right? So now let's try to before jumping into coding, let's try to understand how we can solve this question, right? So when you first see this question, what comes to your mind? So for me, when I first read this question, the first thing that came to my mind is, why not I iterate these linked lists? So we have 2, 4, 3. I'm gonna iterate this, so 2, 4, and 3, and I'm gonna store those numbers in a string, right? So what I mean by that is, let's say we have number 243, right? So what I do, I take 2, I take 4, I take 3, right? So I iterate these linked list and I get this number. And what I do, instead of having this as a number, I will have this as a string, right? I will have this as a string. So once this number is constructed, what I'll do is I'll reverse this string, right? So after reversing, this 243 will become 342, right? So similar way, when I have the second linked list has 564. So what I can do is, I'll iterate through the second linked list and I will construct this string, which is 564. After constructing this string, and I'm going to reverse it, so which is going to give me 465. So so after getting these two numbers, I'll just simply add those numbers. So be mindful that this will again give you a string, and we will have to do some parsing to get the integer value out of the string. So in Java, there is this handy method called integer.parseInt, where you pass the string and you get back the integer. So once you get these numbers and reverse it, you just need to add these two numbers, 342 and 465. That is what is given in this explanation, and that would give you 807, right? So once you get the number 807 after adding, um, what you're gonna do is, again you're going to reverse this, because we have initially reversed it. So we're gonna again reverse it, so which becomes 708 now. So now we iterate this character by character and construct our final linked list, which will look something like this. So this is the first initial thought that came to my mind when I first read this question. But then what's the problem here? So this will definitely work, this solution will definitely work. But then if you look at the constraints over here, they say that the number of nodes in each linked list is in the range 1 to 100, right? So which means here in this question we are having three nodes, which is 1, 2, and 3. But then the number of nodes in each linked list can go to a maximum of 100 here, right? So now assume that, let's say, this particular linked list is having 100 nodes. Then what will happen? You will be having 100 numbers, right? So you'll be having something like this. So uh, like for example 9 8 7 6 so it'll go till 100. So this number becomes literally huge. So when you construct this huge string, and then when you try to parse that string into an integer, there are high chances that you might end up in an overflow issue, right? So in Java you have data types like integer and long. They even long will overflow this limit, right? Because you are having almost 100 numbers, and there is a limit with for integer and long. You cannot store infinite numbers in all these data types. So that there is a certain limit for integer range and long range, and this number that you construct here might easily overflow that range. So this might not work. So some people may argue that instead of using integer and long, we can use big decimal, right? So big decimal is another type provided by Java, and that will definitely work. So if you use big decimal, it will definitely work. But is there a better solution, instead of doing all these parsing, converting to data types, and all those tricks? Is there a fairly straightforward way to do this? So that is what we are going to discuss in this video. We are not going to go with this naive brute force approach where we construct the string, reverse it, put it in a big decimal, add, and then again reverse it. We're not going to do all those things. No, we're just going to try to implement an optimized solution, right? So the intuition is fairly straightforward. So we all would have learned addition, subtraction, multiplication during our school days, right? So we are going to use that intuition over here. So what did we learn in our school days? So consider this, consider you have two numbers like this. Let's say you have 2, and then you have 4, then you have 3, and then you have, let's say, 5, and then let's say you have 6, and let's say you have 7. So if we are asked to add these two numbers, how are we going to do that? How are you going to add these two numbers using pen and paper? What we do, we first take these two numbers, 3 and 7. um, 3 plus 7 is 10, so we're going to put 0 over here, and 1 will be carry forward to the next place, right? So you'll get 1 here, and then you add 4 and 6, which is 10. Then 10 plus 1 is 11, so you're going to put 1 here, and the other one gets carry forward here, right? The other one gets carried forward here, and finally you add these numbers. 5 plus 2 7, 7 plus 1 is 8. So this is how we do our pen and paper addition, right? So we are going to follow that intuition over here, but rather trying to add these numbers from right to left, we are going to add these numbers from left to right. That's the only difference. So you see, if you look at this example, if you're trying to add these numbers simultaneously from left to right, this is what you will get. So when you add let's try to understand this with an example. So I have drawn the exact same example that is given here. So what we do is we add these two numbers plus first. So 2 plus 5 is going to give you 7. So you put 7 here, and then you move to the next position. So you add 4 and 6, which is 10. So when you get 10, so this is like greater than or equal to 10. So what you do is you put the number which is present in the unit place here, right? So if it is 10, 0 is in the unit place, so you're gonna put 0 here, and this particular one gets carried forward to the next place here. Now what you do, you get 3 plus 7, which is 10, and 10 plus 1 is 11. Sorry. 3 plus, I have taken a different example, so it is 5 6 4. My bad. It is not 5 6 7. It is 5 6 4. So we have 2 4 3, and then we have 5 6 4. We have 2 4 3, and then we have 5 6 4. So we add 2 and 5, we get 7. We add 4 and 6, we get 10. So we put the units number as the sum here, and we carry forward the tens digit number to the next place. And now we add 3 plus 4, which is 7, and 7 plus 1 is 8. So we get this output as 708, which is what is expected from us. So this is the intuition we're going to follow here. We're not going to do all those string manipulations. We're just going to go back to our childhood based addition, right? So hope you guys get the intuition behind solving this problem. Now let's try to code it out, right? All right, so we have given two list nodes, L1 and L2. First, let's do some sanity check here. So first, let's check if any of these list nodes are null. So if my L1 is null, I can straight away return L2. And if my L2 is null, I can straight away return L1, right? So if any of these nodes is null, there is nothing to add here. So you just return the other node straight away. So this is some basic sanity check. Okay, now let's come to the actual implementation. So here we have to construct this list. It's not like you get this 708 and you have to construct a new linked list and return that as an output. So let's initialize our result like this, right? Okay, and then let's have a temp variable, just result. All right, so what am I doing here? So I'm trying to initialize my result as a new list node, and I'm assigning that with an initial value. So whatever value that I'm assigning here, it doesn't really matter. So this is kind of a priv, or initial value. You can consider this as a priv. So this is a fairly common technique that we follow when we are constructing a new linked list from the given inputs, right? So you construct, you initialize your result, and then you assign it to some dummy value here. This is not something which we are going to return in our output. So this is just like a placeholder or a dummy value, right? And then we'll have one more temporary variable that points to result here. So I'll tell you why we need this temporary value here. Just hold that thought for a second. All right. So let's try to iterate these two lists. So we have to be really careful while iterating these lists, because the length of these two lists need not be the same. So in this example one, you can see the length of these two linked lists are 3 exactly. But then if you look at example 3, you see the length of L1 and L2 is different, right? So you should not assume that both these lists will have the same length. So it can have different lengths as well. So what we are going to do is we're going to have a while loop. It says while L1 is not equal to null, or L2 is not equal to null. So why do I need an or condition here? Because L1 and L2 are of different lengths. We have to assume that L1 and L2 can be of different lengths here, right? So when I'm iterating L1 and L2, L2 will be finished very soon because L2 is having only few nodes, whereas L1 is having more nodes. So we have to make sure that we are iterating these two lists properly. We should iterate these two lists completely, right? So if you're having an and condition, you might not complete any one of the linked lists totally. So for that reason, we have this or condition. All right, all right, okay. So what we do is we will get the value of these two nodes. So I'll have one variable called as int l1 val. Um Initially I will assign that to 0, and then I'll have int l2 val. I'll assign that to 0, and I'll make a sanity check here. If my L1 is not equal to null, then my L1 val is nothing but L1 dot val. And similarly, I'm going to do a sanity check for L2. If L2 is not equal to null, then L2 val equals L2 dot val. So I'm just checking if my particular my current node is not equal to null. If it is not null, I'm just going to hold that value in a variable which is L1 val, and here it is L2 val. Simple, right? So once I get the value of these two nodes, I need to add them now, right? So how am I going to add it? So I'll have a variable which is called as sum, which is nothing but your L1 val plus L2 val, right? But before doing this, if you go back to our example here, whenever you are adding these two numbers, if that addition is greater than or equal to 10, then you will have to put only the units place number in your sum, and the tens place number will be carry forwarded, right? So we have to incorporate that as well in our code. So how am I going to do it? So I'm going to have a helper variable. I'll call that as carryover. So initially it will be 0, right? So what I do is, if so I'm just going to add int L1 val and L2 val and put it to sum, and I'll also make sure I add if there is any carryover. So whenever first you add 215, it will be 7, and you don't have carryover anything, right? So the initial carryover value is 0, so this sum is going to be 7. But if your sum is greater than or equal to 10, right? For example, you take this node 4 and 6. When you add 4 and 6, it becomes 10, which is greater than or equal to 10. So if that happens, then you have to take only the units place here and put that in your sum, and the tens place number will be carry forwarded. So that is what I'm going to do now. So now what happens is I'm going to construct this result node, which will be temp dot next, which is going to be new list node, and what I do is sum modulus of 10, right? So when I do sum modulus of 10, it is going to give me the units place number here. So if my sum is greater than or equal to 10, I'm just going to do sum modulus of 10, and I'll get in this case I'll get 0, and 0 will be considered as your new node here. Fairly straightforward, right? So once that is done, if not, if your sum is not greater than or equal to 10, then it is fairly straightforward. What you do, temp dot next equals to new list node, and then you just straight away put your sum here. But then there is something which we missed here. So once you get the units place, we should also carry forward the number to the next position, right? So what we do is we do carry over equals to sum divided by 10. So whenever I do sum divided by 10, it's going to give me the units place number here, and that will be assigned to my variable that I have put here. Fairly straightforward, right? It's easy. So let's try to reiterate what we have done till now. So first we get the value of L1 and L2. We check if both these nodes are not null. If they are not null, we are going to get the value of L1 and L2, and then we are going to calculate the sum of L1 and L2. So for the first time, carryover is 0, so this doesn't really make any difference here. But then as you are iterating, if your sum becomes greater than or equal to 10, you make sure you put only your units place number in the sum, and whatever is there in the tens place, that will be carry forwarded. So to get the units place, you do modulus of 10. To get the tens place, you do the dividing of 10. That is all we are doing. So once this is done, let's move to the next node, temp equal to temp dot next. All right, fairly straightforward. So this is the core logic that we do, but there is one small edge case that we need to take care here. uh, that edge case is, so whenever you are carry forwarding stuffs like this, and whenever your input lists are of different sizes here, right? So you have L1 and L2 which is of different size. We need to make sure we don't end up in any null pointer exceptions. What do I mean by that? So for example, let's say this guy ends soon because this is having only few numbers, whereas this guy will take more time because he's having more characters. But as and when you are iterating, you should make sure that you're not doing your operations on a null value, right? So you should always do that sanity check because both these are of different lengths. So how am I going to do that? It's again fairly straightforward process. So I'm going to check if my L1 is not equal to null. If not, I'll just do L1 equal to L1 dot next, and if my L2 is not equal to null, I'm gonna do L2 equals to L2 dot next. Simple, right? So yeah, this is the core logic. So once you are done with this iteration, there's one more edge case that you need to take care of. So whenever you are carry forwarding all these numbers, uh, you, you you need to make sure that you don't miss out the last number here. For example, let's say instead of 3 and 4, here we have a value like 9. All right, so when you add 3 plus 9 plus 1, it's going to be 13, right? 3 plus 9 is 12, 12 plus 1 is 13. So you put 3 here, and then you carry forward 1 to the next position here, right? So but note that this one is out of bounds, or it's like out of the range of these two linked nodes, right? So you have completed till here, but then this one is not taken care of. We need to make sure that this one is also included in our result. So that is one edge case we need to take care of. So how are we going to do that? You just need to check if my carryover value is greater than 0. It is greater than 0. I do temp node next equal to new list node of carryover, and then temp equal to temp dot next. Right? So now this is our logic. Then finally we can return result dot next. All right. So while starting this code, I told you that we are assigning this result to a temp variable. So the reason we do that is uh, if you're using result directly, as and when you iterate this list, your result also gets move also moves forward, and your result pointer might be present somewhere in the end, maybe in the tail. But we need to make sure that we always return the head of the linked list, right? So that is why we have this temporary variable. So this temp is also pointing to result. So this temp always points to the, sorry, this result always points to the head. So since we don't want this -1 value, which is a dummy value that we initialized earlier, I don't want this dummy value as part of my input. So that is why I do a next, so that my actual value, I mean, the output is started from the actual value. All right, that is all. Let's try to run this code. Okay, there is a null pointer, or what did I do? All right, so there's a typo. It's not equal to null. So let's run one more time. Hmm, there is something wrong here. Okay, let's see what is wrong. So we add 2 plus 5, which is 7. We add 4 plus 6, which is 10. So 1 is carry forwarded. So 3 plus 4 is 7. So you got 8. And then this one got added additionally. Why was this added? All right. So there is one thing that we did not take care of here. So what is that? So whenever we are doing this carryover, right? So there might be, I mean, you might end up in a list where you don't need to carry over anything. For example, let's say here 4 plus 6 is 10, so it is 0, and you have 1 over here. And let's say we have 2 here instead of the initial number. So you add 3 plus 2, which is 5, and 5 plus 1 is 6, right? So notice that this does not have any carryover because the number 6 is less than 10. But then you see the value 1 is assigned to carryover a variable, right? So we need to make sure that we reset this carryover when your sum is not greater than or equal to 10. So that is something which we have missed. So let's do that here. So what I'm gonna do is I'm gonna I'm gonna check I'm gonna check if my sum is less than 10. If it is less than 10, I'm just going to reset my carryover to 0. All right, think it should be fine now. All right, got accepted. Let's try to submit this code. Sure, worked. So so this is the intuition and code, guys. Let me know what you think. See you again in another video. Thank you. Bye bye.